I sent an original data set to Syntho and they synthesized this data set. But the question was also, well, let's compare it also to anonymization, because we already talked about anonymization. We said, well, you lose a lot of information in that anonymization data set. Well, is it really true? So what we did, I had this data set from telecommunications industry, 56,000 people. People having left the company, so there's churn. It's a churn case. That's the target for my modeling. A lot of inputs, 128 inputs, potential features for the models. So it was a great data set to build some analytical models. And we gave it to Syntho, and they, of course, synthesized the data set, but also we tried some anonymization techniques. And then when I received both data sets, I started modeling using SAS. So I built a churn model on the original data set, and actually a couple of models. I used classical regression techniques, classical decision trees, but also more sophisticated techniques, neural networks, gradient boosting, random forest, these kind of techniques. And I used the standard options of SAS, because I didn't want to tweak the model too much, because then you don't really can compare it. So the standard options of SAS, just use SAS, build some models, and look at the results. And the results were very, very promising, not for anonymization, but for synthetic data. When you use it for, you look at the results for anonymization, we look at, and for the non-machine learning experts in the audience, we look at the area under the curve. And the curve, that is the ROC curve, and that's, well, telling you something about what are the true positives and the true negatives in your data. Is the accuracy of the model okay? And when you compare it in the original data with the anonymized data, we see that on the original data, the area under the curve is 0.8. And on anonymized data, it's 0.6. And the maximum would be 1. An optimal model would have 1. So 0.8 is rather good. But 0.6, well, a random model should already have a half, 0.5. So we can't really use that anonymized model, because you lose a lot of information, a lot of predictive power. But then the question is, what about synthetic data? So the next step, we did the same. We sent the data to Syntho AI. We have the synthetic data set. We built some models, the same algorithms, the regression models, neural networks, gradient boosting, etc. And now, of course, on the original data set, still we have the 0.8 area under the curve. But also on the synthetic data, now we have 0.8 under the curve. So it's very similar, not exactly the same. In fact, it was a little bit better, but that's more or less the variability. Yeah? So the data is not exactly the same, but a little different. So it is very promising. We're very happy about this.